Hi, everyone. Welcome to the second Algorand Educate event of 2022. Today, we're hosting Ryan and Russ from Algorand, who are going to be talking about the layer one. So I'll hand off to Ryan and thanks.
Thanks very much, Vanessa. Let's do this. All right. Welcome back, everybody. This is our second of three different sessions here from Algorand. My name is Ryan Fox. I am a developer advocate here, along with my colleague, Russ Fustino. Russ, give us a hello.
Howdy, everybody.
All
Everybody's
right.
doing good and getting ready for the weekend.
That's right. So good afternoon, good morning, good evening, wherever in the world you are. We're thrilled that you're here. Welcome, friends. Let's build some Web3 together. So look at those are my QR codes. That's me before I joined Algorand as a developer advocate, and that's me now as a Web3 builder. You can be like me too. Just follow along here. So let's see what we're going to do today. We have got an agenda here. So again, I'm sandwiched between the intro that Russ gave just yesterday and the building dApps section that's going to come up in a couple more weeks from our boss, Jason Weathersby. But today we're going to be focused on your developer environment. How do you get that set up? And then we're going to go through a little workshop. We're going to get started building. We're going to figure out some of the primitives that we have on the layer one and get you into some code. So all of the slides that you'll see here are available on the GitHub repo. You'll see some QR codes in here as we go through the deck. So if you want them, shoot them, jump in, follow along. But I'm going to go relatively quickly for this so that we can get it all covered and then allow you to watch this video again and be able to follow along and do all of that for yourself. So we'll get that out of the way. Here we go. So today for our developer environment setup, we have a GitHub repo for you. Our Algorand developer relations team here, along with Encode Club, we equal this QR code and it'll take you over here to this workshop getting started guide. And I want you to do this. You can either jump to it straight away or just know that it's there. Again, it'll be in the slides when we come, but we're going to have you look at the README file. And essentially we're going to follow along with this today. Before we jump into that, I want to make sure that you guys have awareness about our developer resources, knowing that the Algorand developer portal is here for you to get you connected. Let me just quickly show you what that looks like here. So that is actually this direction, right? Here it is. Oh, it has this really cool animation when you load it, right? It comes in and it shows you. All right, so yesterday, Russ took a look at the blockchain's basic stuff, so went over that section of it. Upcoming, Jason's going to talk about smart contracts and building dApps. Today, I'm actually going to talk a little bit about tokenization, and you can get into these other bits on your own. A little bit about the navigation of this site. It has this awesome search bar here, so if you have a topic about whatever it is that you want, it's going to, as you start to type, it's going to bring it up here. Make sure that you're making use of that search bar in order to help your learning. We have a whole bunch of documentation for you. Today, what I'm going to cover is really what's in this getting started section. Once you understand that, you're going to spend most of your time in the getting details section, and then you can take some spotlights on some other bits here. Also around the corner here on this left nav bar, let's zoom in just a little bit right here. So you can blow it up to see what's in the getting started pieces here, and the get details have lots and lots of stuff that you're going to want to use. But importantly, you're going to want to learn about our SDKs. We've got them available in Python, JavaScript, Go, and Java, as well as from our community in C# and many other SDKs as well. And then our APIs are also illustrated here. You're going to be focused on the V2 one. So just a little bit about how this is all organized here. You'll want to become familiar with that. And then as well, you'll want to focus here on our developer blog. This is where we're getting examples and articles and solutions and tutorials from our community members and also from from our team here as well. This one is showing how you can use one smart contract to spawn additional smart contracts, and talks about how our application binary interface works with a parent contract in order to interface to some other child contracts as well. So this blog has all sorts of interesting content for you to see. And it's organized by tutorials as well as solutions here. Then these will all have a bunch of code available for you so that you can get in there, go through them. Here's the Mora game. I think Russ showed this yesterday, but he's got a tutorial that has the code here. Plus it gives you the walkthrough of what it does and how it does it, and then how to set that environment up as well. I want to make sure that you guys are familiar with our Discord server. So up here in the navigation bar here is the link to the Discord server. That's for asynchronous communication. That's over here. Let's get this mess out of the way so that you can see it here, right? Our Algorand Discord server is your place to get your questions answered. There is so much going on here. It's organized for all of the different topics that you would like to focus on. So if you are building and you want to learn about NFTs and arts or how the dev tools are working, there are bits for all of the SDKs, all the different languages, and all of the different types of solutions that you want to build. As you can see here, I've got lots of unread messages. My colleagues are there all the time, and they are ready to answer your questions here. So as you can see here, Algorand Inc., here's the guys that you want to see. They're all online and they're ready to help you. Make sure you check that out. And again, you can get to that at the top here by following the Discord link. All right. That is a quick overview of that. You can also make yourself an account and you can connect it to GitHub. So that helps you keep connected with us and organize the content that you are viewing and searching on. Let's get back here to the presentation. Let's see what else we've got here. A piece that I didn't show you on there, so I'm going to go back and do it, are the developer environment. So, or the IDEs. Right? You know, when you are thinking about setting up your developer environment, you've really got three components. You've got the IDE, you've got the SDKs, and then you need the network interface. So we're going to show you how to set all of those pieces up. Let me head back over here quickly. If we look at the tools section of this navigation, right, we have it organized by all of these different topic areas right here. Languages, smart contracts, IDEs is the one that we want to look at, but there's also the bits for the SDKs as well. But here, we're going to focus on the different IDEs that we have available. A JavaScript one here from, this is a web-based one from Algodesk, a desktop app from Algo Studio. Algodia is a IntelliJ plugin. And then there is the Algorand Visual Studio Code extension, which is the one that I'm actually going to focus on today. So I use the VSCode IDE. You can use whatever you want in order to write your code, but let me show you how easy it would be if we did that, because we have this nice code extension here. So if you are inside of your developer environment, or inside of your IDE, let's get it right here. It is, yes. And if you come over and you click on your extensions and you search for Algorand, you will see that this comes up right here, and you can have the Algorand VS Code extension installed. I've already installed it here. So this does code highlighting and much more. Next, we are going to talk about the next component of your developer environment, which is going to be that node. So if you want to talk to the Algorand network, we want you to use the Algorand Sandbox to start out. And here's how you get to it. You can just clone this repository here at GitHub Algorand Sandbox, and we'll show you how to get that set up. What is the Algorand Sandbox? How to get the sandbox set up? You're going to run this command sandbox up dev, and that's going to put it in dev mode. We're going to see how to do that in the command line. But what I want to do is explain to you what it does. So the Algorand Sandbox here. So this Dockerized container has all of these different components in it here. And what those components are is a node, so that you have your blockchain ledger where you're going to store all the transaction history, as well as an indexer, which is a database that has been indexed, and you can query this for historical data that has been pulled from the ledger and written into this external database, as well as a key manager or a wallet, something to store those private keys. And then we know that as KMD here. That's what we'll see it listed in our SDKs and documentation. So KMD is the wallet, indexer is that query service, and then AlgoD is the node for the ledger, which you're going to interface with to send your transactions to. Each of those components provide REST APIs here so that you can send your transactions and pull some data from it, certainly pull and query data from that index database, and then have a way to send your signed transactions have a way to send your unsigned transactions to your wallet to then be inspected and ultimately signed so they can then be broadcast back to the AlgoD node. Those endpoints are available on these different ports here for you, and they're automatically exposed through the Docker container here, which is Sandbox. And so you will access them at HTTP and localhost and whichever port it is here. Again, we suggest that you bring your Sandbox environment up in dev mode. So it would be Sandbox up and dev. There are other modes that you can bring it up in, such as testnet, and you may advance towards that after you have got your environment set up locally where it's just a private test network. That's the way that we recommend that you get started building. And that's exactly what we want to do now, is build. So let me go over to yes, here we are. We are now looking at our code. So, oops. And what I have done is we have now downloaded and cloned the repository for our getting started workshop. So again, that was at github.com/Algorand-devrel. And then we're finding this repository for workshop-getting started. And in this, we can see the README here. I think it'll be better if we actually look at it. Oops. So you can follow along on this. We've already done this first bit here, which was to install that VSCode extension. And next it talks to us about, hey, let's install Sandbox. So we want to first clone this repository here at Algorand/Sandbox, move into that directory, and then we are going to issue this command sandbox up dev. So let's do that. I'm in my Sandbox directory because I've already cloned it ahead of time. I moved into that directory. I'm going to paste in this command, and I'm going to bring it up. Now, what we see happening here is a Dockerized instance of Sandbox being created and syncing to, or actually it's not syncing because it's creating a brand new network locally here. So this is a private instance of the Algorand consensus network and providing you all those tools that we saw as well. And it tells you about that. So this is the version. It's the most recent one in the stable environment, as well as for the indexer and the wallet as well. Important things that it also tells us are that it creates a handful of accounts for us, 3 accounts actually here. So these 3 different Algorand account identifiers are created, and each of them has some algos here, or micro algos, as well as it gives us a couple of commands that we can run at the command line that would be issued against the AlgoD node, the node that's running. And we have a tool that is called goal. That is our command line tool to do that. I forgot to tell you about that, but that was actually one of the things that is listed here are the components that are inside of the sandbox, right? LOD is the node, and goal is a command line utility and a transaction builder that then has the ability to interface both to the node and to the wallet. So we're going to use goal here in the command line here today to do this. And we will take this command right here, which says goal clerk send. We are going to send an amount of 1, 2, 3, 4, 5, 6, 7, 8, 9 from address number 2 here. And we are going to send it to address number 3. All right. So let's just simply copy that, because this when we started the sandbox, it knew all this stuff and it did this for us, printed this out here so we can do it, and we can see that that particular transaction was committed in round 5. So because we started our sandbox in dev mode, remember we said dev, up dev, that means that a block is going to be created every time we send a transaction. That is very fast for you as developers, so that you can not have to wait the normal 4.5 seconds that you would on testnet or mainnet in order to have your transactions confirmed. So as a developer, this is why we want you to do it on a private network. Not that 4.5 seconds is very long to wait, but of course, as a dev, you just want it to go, 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 go. So every time that you issue this command, it's going to create a transaction. So now we've sent a second transaction, and you can see here that the transaction that was sent, this was the transaction identifier for round that was committed in round 6, which is different from the transaction identifier that was committed in round 5. All right, very exciting. Another thing that that the sandbox also gave to us was a curl command that queries the transactions on that indexer. Remember, I said that the transactions that are committed to the ledger are then read by this indexer service, which takes those blocks out, indexes all the transactions within them, and then makes them available to be queried. So this very simple curl command will ask for all the transactions that it knows about and print them out pretty. And so there it is. So this actually, if we take a look at the transaction here, we would see that these are the 2 transactions that we sent earlier. Hard to really understand, but I think the important thing to understand is that you now have a way to see the data that is that has been committed to the blockchain earlier in a nice indexable way. We'll see a little bit more about that later. All right, let's take a look back here at where we're going, right? So we've done this. You can also, another thing to do is to use this command here to take a look at those default accounts. We saw them printed up above, but now we've run some commands. We can't see them anymore. We don't remember what they are. If you issue this command, sandbox goal account list, it will then print out all the accounts that are stored in the KMD wallet, right? So that's that command line wallet. And so it shows them again. One nice thing that I suggest, if you're going to use the command line, you are probably going to want to copy those addresses into some command line variable, into some event variables here. So if we do that, if we simply copy this code, that's going to take all 3 of those accounts, and it's going to write them into event variables or environment variables called address 1 through 3. So let's do that. Good. You don't see any output, but trust me, they're there. So now if you say echo $ADR3, you would see that that is in fact the 3rd address in here. So then you can go through and do some other interesting things, like here's another command that is going to show us what the account looks like on the ledger. So the current state of account at address number 1. We will do this. And it didn't like something. What did I do wrong here? Unknown flag account. How about just that? Okay. There. You just have to say minus A instead of minus account. So might have to update the doc on that one. All right, so this is showing, again, all of the information, the current state about this account. Really, it's really all that we're seeing right now is the balance of the micro algos that it's holding. Oh, look at this one. I've actually run this one before where it created a token already. So it shows that it has already some tokens associated with it and some other information about participating in consensus and how it's voting. All right. We will move next away from the command line and we're going to get into some SDKs. All right. We already saw doing the first transaction because we already copy and pasted that. So we already did this query piece, right? So now let's move along and talk a little bit about those REST APIs that we have. So we talked about the three different components that we have here for the AlgoD node to get to the ledger. If you want to use when you're going to use your SDK in order to connect, it's going to ask you when you say new client, it's going to ask you for, hey, what's the address and what's the token to get to the AlgoD node. How do I access the REST APIs? Here's the documentation to get to it. This is what you'll need to do. Similar for the wallet. Of course, it's a different port number, but it does use the same token. And then the indexer is on a different port number yet, but it does not require a token. So we'll see that when we look at our SDK documentation. And when we instantiate those clients. So let's do that. Algorand provides these different SDKs here in Python, JavaScript, Java, and Go. We know that we saw yesterday that about, well, more than half of you, I think it was about 2/3 used Python as well as JavaScript. So I'm going to go through and do some Python stuff today. This, you could certainly see examples of this on the developer portal in all of these languages that you'll see here. We also have a number of community supported SDKs. Let me actually just do this one because I did not show you this earlier, but we have SDKs for .NET, Dart, PHP, Rust, Swift, C++, Unity, and another one for .NET. So lots and lots of availability for you, if you were a developer, to begin writing the code in whatever language you are comfortable in. All right, so for me, I'm going to make sure that we are using the latest version of the Python SDK so that we can install that. That's pretty simple. So I'm going to head over now to my IDE here, and we are going to try to make this get a little bit smaller. Oh, come on now, drag down, drag down. All right, let's just get open a terminal window here for us that is not the Sandbox. So I'm going to go to my home directory where this is at. Here we are. And I am going to use pip to install the latest Algorand Python environment, or I'm sorry, latest Python SDK. So now we're up to date with that. And we can now begin to take a look at our first example. Our first example here is going to generate a new account. All right, so this code is very, very simple. All right, we are looking to generate an Algorand key pair. All right, so Russ showed you a little bit about what accounts look like yesterday in the intro one. So we're going to do this. All it's going to do is print out what the address and the private key, as well as what the passphrase is, by simply calling the method generate account. In order to do that, we first need to ask our Algo SDK to import a few of the libraries from that SDK. So we need account and mnemonic. So let's just run this and let's see what it looks like here. Right. Apparently I can't spell Python. There we are. Yes. Let's do this. We just see the output. All right. So we see that my address is Charlie Sierra for November, and my private key is 32 bytes, but it's base 64 encoded, so nobody can really read and make any sense of that. So really what we want to focus on is this passphrase. And so my passphrase is actually these 25 words here, which is a standard format for storing seed phrases here, 24 words plus a 25th word checksum of those 24 words. You can use this in your you can use this within your SDKs and your sample applications if you would like. My suggestion is that you are connecting to the KMD wallet, like you'll see in my upcoming examples. And rather than putting this in your code, because you run the risk of uploading it to GitHub and forgetting that you've done that, and having somebody come in and steal your value in the future because you have exposed your private keys. So this is something that you never want to expose to somebody else. One interesting thing about this method here, generate account, is that every time that you run it, I'm going to move this up a little bit so that we can run it again. All right, so every time that you run it, you get a different account generated. So this address, like I said, was Charlie Sierra for November. If we run it again, it now gives us this one here, Julia Kilo Uniform. So every time you do this, you are going to get a new address generated, and you will get a new set of words here. Your passphrase will be different every time as well. So this is how you can generate a new account. It doesn't cost anything to generate accounts, but of course there isn't any value there until you send a transaction to it. That is what we're going to take a look at next, is looking at account balances. So using the Python SDK this time, we are going to take a look here at what we are importing this time. So this time we are going to import KMD, which is the key management data daemon, or the wallet. And so we are going to import that, the wallet, as well as the V2 client to Algorand so that we can connect to the node. So here is where we see us actually setting up the variables for the KMD and Algorand instances here. We see those port numbers and tokens that we need that are provided automatically. So in our main, what we are going to do is first instantiate a KMD client, and we simply pass in the token and the address. And then we are going to ask it to connect to a specific wallet. And because Sandbox is this Dockerized container that we know every time that it creates it the same way, it creates this unencrypted default wallet for us, and it gives it no password, so we can connect to it easily. If you were going to create your own wallet on there, you would have to modify these variables appropriately. All right, so then we are going to automatically gather the 3 default accounts that are contained within that wallet. And so we will just ask it for the wallet addresses at these indices and write them into these variables here for us to use. So next, after we have talked to the wallet, now we are going to try to talk to the Algorand node and get some information about the current state of one of those accounts. Oh, actually all these accounts. So we're going to create a client. That's as simple as saying algod.algod client, passing it the token and the address once again. Now we have a connection to that node, and we can use the client account info method here and pass it in one of those addresses, and it is going to tell us what is the balance of each of those addresses. Very exciting. All right, let's do it. Let's see what it looks like. Oops. And if we go Python 2, it's going to tell us that those three addresses have these balances. Now, of course, those look very similar because that's exactly what we saw if we ran the Sandbox goal account list command. It would show us those exact same things. That's in my other window. And you saw it earlier, so we don't have to go and show it. All right, good enough. Let's move along into creating a payment transaction. So we saw doing the payment transaction from the command line, but let's see what it looks like doing it inside of using the Python SDK. So what's new here? This time in our or from our SDK, we want to import the transaction or the transaction object. So we're going to now make use of that. Everything else we've seen here, we're familiar with connecting our clients, right? All right, we're getting those accounts, nothing new there. So let's go through and build an unsigned transaction. So what we need to do in order to create an unsigned transaction, which is happening right here using, Control-Z, using the payment transaction method here, it's going to require that we have an address. So we're going to use the first address. This is going to be from, and this is going to be some suggested parameters. Now we can get that easily by using this suggested parameters method here that the Algorand client will return to us. All right, so we ask it, and this is information such as, hey, what block are we currently at? And what's the hash of the network that we are connected to, so that we don't have to type all that stuff in. And it'll help us set some values that this transaction needs, like the first valid block and the last valid block for transaction verification. So we've got who we're gonna pull the money from, where we're going to send the money to, how much we're going to send, and if we're going to add a note. And in this case, we are, and we are simply going to say GM because let's face it, we're Web3 GM. All right, so for that string GM, we have to encode it. So you just call that, and it will base64 encode it automatically for you. That's the first step. Sign that transaction. The second of three steps is to sign the transaction, and third, we're going to submit it. Signing it is pretty easy. You simply just take this unsigned transaction object that you received from this payment transaction method and call sign. And all that you have to send this method is the address, I should say the private key at a particular address, right? So we are now asking the wallet object to export the key, the private key for this particular address. And then it will put a signature on top of this transaction. And lastly, we will submit that transaction to the blockchain using our Algorand client and the send transaction method, right? And we are simply passing it that signed transaction. And hopefully it will say that we have successfully confirmed it. So we'll wait for that transaction to come back. Let's see what that looks like. Python, what are we on, number 3? All right, let's run it. So we're going to run a payment transaction. And we got that back very, very quickly because, of course, in dev mode, the transactions are processed automatically. So we see that we successfully sent a transaction with this identifier, and the transaction looked like this. It says which round it was confirmed in. Here are the transaction details, including the amount that we sent. So that matches what we had in our script above. And it is showing who received it and who sent it. So that would match what we have in our script above. And the last piece that it printed out here is that decoded note. And of course, it says GM. So that's good. So if you wanted to modify anything within this script, it's quite easy. If you want to send, a little bit different number here, go for it. And if you want to change what you're saying here, right, you can say, hi, Russ. How's the pizza? We know Russ. He loves
Awesome, baby.
All right. So if we save that, all right, and we run that again, what are we going to get? Did I not save it? I didn't. Control S. Here we go. Let's send it again. We've got a new transaction. Importantly, you will notice that it has a different transaction identifier. It has a different amount. And of course, we have now posed that question to Russ. All right, so that is sending a transaction using the, or sending a payment transaction using the Python SDK. Next up, we're going to take a look at gathering account information from using this SDK. Nothing new up here. The imports are the same. We're still going to use the wallet and KMD and AlgoD in order to connect to our wallet, and we are going to get those accounts. And what we are going to do here is check the account details, right? So we want to see what information is held for each of those 3 accounts that we have. So let's just do that. We're on number 4. Here we go. So we ask it, what do you know about each one of these accounts? And for each one of these accounts, it says the account information for this particular address says that this one has a whole lot of micro algos, and it does not have any assets. So we're going to talk about assets next, but those are tokens, right? And they will have an identifier, and we will see that when they are holding assets, this section will be filled out. When we create assets, that will be noted here on the creator's account, which will be, I'm highlighting apps. So it'll be similar for assets and apps. If you create a new application or you create a new asset, those will be displayed here. It tells us about our minimum balance. Minimum balance, you'll come to understand on Algorand, is essentially prepaying for storage space for the assets and application data that you want to make use of within the blockchain system. So for each asset that we hold, we have to have a minimum balance of 0.1 algo available. Similar for application state. There's some documentation on how the minimum balance is calculated, but it's nice to have it here for you to see how much of your account balance is contained within your minimum balance. And then again, this participation section is all about participating in consensus. This might be empty for your account if you are not participating in consensus, but these, because they're running this private network, they are actually doing that. So you will see that. All right, let's take a look now at creating assets. So Russ told you yesterday about assets, and what we want to be able to do is create an asset. And what we're going to do using the Python SDK, nothing new up here. Again, we're going to use transaction. We're going to connect to our wallet. We're going to get those accounts. This time we are going to, so we're going to follow the same 3 steps, right? We're going to build an unsigned transaction, we're going to sign it, and we're going to send it. But the type of transaction that we are going to build this time is different from what we saw before. So before we did a payment transaction, and this time we are going to do an asset config transaction. So that looks like this. All right. So all of this stuff here talks about the asset config transaction. And what we're going to do is we are going to say that we want to create a fungible token having 1,000 units. And we pair that with the decimals down here to show how many decimals we want to have for this one. So 2, which would mean that in fact we are only creating 100.00 units. All right, so we're defining 10,000 as the total, but we are saying that the precision of this particular asset is 2. So therefore we are actually creating 100.00 units of this. All right, and this one we're going to call it the funky token, right? So we've given it a name. We've given a short name. So this is like the ticker symbol. That can be up to 8 characters. You can give it an asset name. That can be up to 32 characters. We are going to talk about who is creating it and who could be the manager of it here. So we're defining that as address 1. And what else we got? We are taking away the ability to have freeze, clawback, and reserve. Those are some advanced features that we will teach you in the future about. And then we are going to show an example here where you would have the URL field populated by a path to your fungible asset metadata.json file. So if you are familiar with creating assets, you would know that you want to define your metadata about this asset off of the blockchain, and we will reference that here so that everybody knows where to go and get it. We'll show you some resources on the developer portal about the specifications that define that. These would be ARC3 or ARC69 in Algorand parlance. These are very, very similar to ERC20 or ERC721 if you're familiar in the Ethereum space. Right, so we are going to create this transaction, and again, the sender of this one is going to be address number 1, and they are going to then sign that transaction and submit it just the same, and we'll wait to see what it looks like. So let's run this one. We are on number 5. And when we create this asset, it will have a lot of output here. The important thing to understand here is that we will see that it came up with an asset index of number 11. So this is saying that this fun token, our new token, has an identifier of 11. So in Ethereum, you're going to be familiar with assets have a contract address. Here you get an asset identifier. Similar for applications. Jason will show you doing applications. Applications will also get a uint64 value for the for their identifier as opposed to a contract address. All right. This is the information that we put in to define it up above, right? So we have this URL that shows where the metadata is at, our unit here, our ticker symbol, and what else does it show in here? Yeah, how many there were, right? Okay, it's total, and then the decimals, right? So the precision there. So all those values that we had up above. All right, now if we go back and we run that account info again, what we will see this time is that on that address number 1, they are going to have some assets created. So we got to scroll up and find where that one is. All right, we're looking, here it is. All right, so so this here is that this is address number 1, and as you can see that they have created assets. And I ran this before. You didn't see this, but I ran this earlier, and it created asset ID number 2. What we actually saw was it creating asset ID number 11 here. So there's all the data that we saw in that transaction. This means that now all 100.00 of those assets are held in this account here, and when they move them around, they will show up in the asset in the assets portion of those other accounts. So let's see that happen. One thing to understand about Algorand is the opt-in feature here. So from a spam protection point of view, opt-in ensures that you don't get a bunch of crap coins coming into your account and polluting your wallet, raising your minimum balance. The opt-in feature in Algorand says that you, as the account owner, must want to hold a particular asset before somebody can send it to you. So in this case, we have our fund token number 11. We need to opt into it before somebody can actually send it to us. So to make an opt-in, what we are going to do in our code here, it's going to be another, it's going to be an asset send transaction. So we're going to see that. But we have to change this. This is in the code. You have to change this. Change it to number 11, right? Because that's the index that we have for the fund token. And don't forget to save it or it won't run. But what we're doing here is we are going to build this unsigned transaction for an asset opt-in transfer, or for an asset opt-in transaction. All right, and it's just going to take the sender, the parameters, and then that index number. And this is a zero value transaction that just indicates to the blockchain that yes, in fact, you want to hold this particular asset in your account. So after we assign and broadcast that, it'll just say, okay, you can hold that one. Let's take a look at that. Now, who's doing this? Address number 2 is doing this. So let's run it. And then we'll take a look at it. So we're on number 6 to opt in. Here it goes. All right, so it successfully opted into that in this transaction. So it was confirmed here, and the transaction showing that it wanted to opt into asset identifier number 11. All right, so now if we go back and we run that account info this time, what we are going to now take a look at is that second one. So here, this is number 3. It hasn't created any assets or apps, and it's not holding any assets. But this one here, number 2, will now be holding some assets. And if we look at it here, assets, it is holding the amount of, well, I already ran this, so it's holding 2, right? 11 is the important one to look at here. It is holding no asset 11 because all it did was say that it wants to have it. This was not here before. I should have shown you that. But it now has the ability to hold that fund token in it, whereas this other account, address number 3, it does not have any assets shown. Assets here is blank. All right, let's move along to the last important thing that I'm going to show you today, which is atomic transactions. And Russ showed you what atomic transactions were visually the other day, where we were ensuring that multiple transactions all execute successfully and commit to the blockchain, or if any one of those component transactions in that atomic transaction group fail, none of them will be committed to the ledger. So what we're going to do in this example is we are going to say that account number 1 is going to pay for some wants to buy some of wants to buy some asset, some of those fund tokens at asset ID number 11. So we have to define that in here. Let me there's again, nothing new at the top, right? Everything, we're going to get the accounts, we're going to do all that. So we are sender. So sender number 2 is going to send some algos. Just going to send one algo to address number 1 in exchange. Address number 1 is going to send to address number 2 10 of the identifier number 11, saving that. And so what's happening here? All right, we've seen, or actually this is the first time we're seeing this. We are going to use the asset transfer transaction method here to send from to amount index, right? So we've kind of seen this earlier with the payment transaction, but we'll see that it's different here. So this is the asset transfer transaction that's going to transfer our asset number 11, and that's what address 1 is going to be doing, whereas address 2 is going to be doing what we saw earlier, which was just the normal payment transaction. Payment transactions move just algos. That's the only thing that a payment transaction is able to move. And asset transfer transactions are able to only move ASAs, Algorand standard assets, or these assets that we have just created here. All right, so we have 2 unsigned transactions. What we must do next is group those together. So we need to create a group identifier by calculating that group identifier of the specific order of transaction number 1 and transaction number 2. And when we do that, or how we do that, actually, when we do that, we will get that single group identifier and we will add it to the transaction 1 and transaction 2 so that both will have that in there, meaning that they are now coupled together in an atomic transaction. Independently, we are going to sign these 2 transactions. So we'll notice that transaction 1 is being signed by address 2, whereas transaction 2 is being signed by address 1. And they are signing over that group identifier in their respective transaction. Then we will assemble those transactions in the order that we had before into a signed group. And then we will submit that transaction group to the blockchain for evaluation. Notice that this is send transactions, plural. Before we were sending just, we were using the method send transaction, single. And so here we're using a signed group, whereas before we were just using a signed transaction. What's important to understand is that if you don't have the transaction identifier over all of the transactions that you want to group together, they won't be executed together and atomically. If in this example, let's just run it to show you that what it does and that it works here. So if we do the Python, we are on number 7 here, and when we run this, we are going to see that that transaction group executed successfully. This was the transaction identifier, and it was confirmed in round number 12. And we have it only returns the first transaction. This one I didn't show it showing both transactions here, but this was the payment transaction. But we will know that the other one happened when we look at their balances. So now if we go to the account info, and if we take a look at account number 3, we will see that the assets have now gone up, and actually not account number 3, account number 2, I'm sorry. Assets. Let's find it here. Okay, yes, here it is. Assets with the asset ID of 11, their amount is now 10, right? Before this was 0. So if we do it again, we'll do it faster. Oops, we don't need to do that again. We need to send it again, and this time we're going to see that it's 20. So now if I do account info, and we scroll up and we say, yes, in fact, for this account, for this and for this asset, the amount now has gone up to 20. And we don't really remember what the how many algos that first account had, but this number has been going down by 1 million micro algos as well. So those are executing both simultaneously. If we did something like this, where we would say in our code that address number 2, let's see here, sender address 1, right, who was the creator and had all of those tokens. Let's say that they said that they wanted to send all 100 of them. Of course, they're not holding 100 of them anymore. They're only holding, I think, 80 of them now. But if they tried to send more than they hold, saved it, let's run it again. We'll show that this transaction is going to fail. Did I not save that? Transaction information. And then we will look at the account information here, and we will see that the balance, where is, let's do it this way. We have this other one, right? Get balance, Python, what was it, number 2. Let's do this, because this should show us all of, oh, that one only shows the balance of microalgos. Well, we have assets are there, and assets are here. 120. How many did we create? I thought we only created 100. Well, I will, trust me, atomic transactions work that way. I must have put a fat fingered it someplace else, and I apologize, because we are to the end of the demonstration here, where we have gone through all of the demos that are in this workshop. Again, you can follow along and do all of these within the README file here. The last part of this is here, right? So we're done building, and I just want to say thank you very much to the Encode Club for hosting Algorand here, and thank you everyone for being here. We look forward to having you build. We'll see you on our Discord servers. We will see you on the Algorand developer portal, and we look forward to seeing you back here in a couple of weeks when my colleague Jason will be here to demonstrate building smart contracts. So until then, have fun building on Algorand.
Awesome. Thank you guys so much once again for these 2 awesome workshops. We're looking forward to seeing everyone again once the hackathon kicks off at the end of May. I've posted some links in chat if you want to sign up in advance, but keep an eye on our Twitter. We'll be posting an official hackathon announcement featuring more details about the challenges and the prizes, which I'm sure everyone is wondering about. So keep an eye for that. And yeah, we're looking forward to seeing everyone and to seeing what you guys are going to build. So thank you so much once again, and see you in roughly a month. Bye.
Bye.
Bye-bye.